Good morning, students. So, in today's class, we will discuss about the second chapter of first PUC, that is atomic structure. Okay, so before proceeding to the problems, let us briefly go through the gist of this particular chapter. So, in this particular chapter, we will be discussing about the subatomic particles in the beginning ಅಲ್ವಾ ಫಸ್ಟ್ ಗೆ ಈ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ನಾವು ಸಬ್ಅಟಾಮಿಕ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಅನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೇವೆ ಸೊ ಡಾಲ್ಟನ್ಸ್ ಥಿಯರಿ ಪ್ರಕಾರ ಅವನ ಏನ್ ಹೇಳ್ತಾನೆ ಆಸ್ ಪರ್ ಡಾಲ್ಟನ್ಸ್ ಥಿಯರಿ ಆಟಮ್ಸ್ ವರ್ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ indestructible. Okay, but the later whatever experiments done, whatever based on the observations of the new discoveries, it is found out that the atom also contains some subatomic particles like electrons, protons, neutrons, mesons, etc. ಅದರಲ್ಲಿ ನಾವು ಇಂಪಾರ್ಟೆಂಟ್ ಸಬ್ಅಟಾಮಿಕ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇಂಪಾರ್ಟೆಂಟ್ ಸಬ್ಅಟಾಮಿಕ್ ಪಾರ್ಟಿಕಲ್ ಅನ್ನ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡ್ತೇವೆ ಈ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ, ದಟ್ ಇಸ್ ಎಲೆಕ್ಟ್ರಾನ್, ಪ್ರೋಟಾನ್ ಮತ್ತೆ ನ್ಯೂಟ್ರಾನ್ ಅನ್ನ. ಓಕೆ, ಸೊ ಈ ಪಾರ್ಟ್ ಇಂದ ಹೆಚ್ಚಾಗಿ ನಮ್ಮ ಚಾರ್ಜ್ ಮೇಲೆ ಬೇಸ್ಡ್ ಆಗಿ ಸ್ವಲ್ಪ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಥವಾ ಮಾಸ್ ಮೇಲೆ ಬೇಸ್ಡ್ ಆಗಿ ಸ್ವಲ್ಪ ಪ್ರಾಬ್ಲಮ್ಸ್ ಕೇಳಬಹುದು ಅಲ್ವಾ. ಸೊ ದಿಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ವಾಸ್ ಡಿಸ್ಕವರ್ಡ್ ಬೈ ಕ್ಯಾಥೋಡ್ ರೇಸ್ and it carries a charge of minus 1.6 into 10 to the power minus 19 coulomb, and mass of electron will be 9.1 into 10 to the power minus 31. Anantara this ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಡಿಸ್ಕವರಿ ಇಟ್ ಈಸ್ ಬೇಸ್ಡ್ ಆನ್ ಕ್ಯಾಥೋಡ್ ರೇ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್. ಕ್ಯಾಥೋಡ್ ರೇ ಟ್ಯೂಬ್ ಅಲ್ಲಿ ಅದನ್ನ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡ್ತಾರೆ. ಹೈ ಎಲೆಕ್ಟ್ರಿಕ್ ಡಿಸ್ಚಾರ್ಜ್ ಇಂದ when a high electric discharge is passed through a gas, it is observed that some ray is emitted from the cathode, and that is called as the cathode ray. And ಅದರ ಚಾರ್ಜ್ ಅನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದಾಗ it was carrying a negative charge, and it had a mass of this 9.1 into 10 to the power minus 31. Okay, and then proton was discovered. It is also called as the anode ray, and proton, it is observed that it was carrying a positive charge, and it is equal to plus 1.6 into 10 to the power minus 19 coulomb. And mass, it is observed that it is 1.67 into 10 to the power minus 27 kg. So you can observe here electron ಮತ್ತೆ proton ಗೆ ನಾವು ಡಿಫರೆನ್ಸ್ ನೋಡಿದ್ರೆ there is a difference of around 10 to the power 4. So electron in a mass is very negligible when compared to the proton. Okay, and then later neutron was discovered, and this neutron was discovered by bombarding alpha particle on the thin sheet of beryllium. Okay, so our experiment ಮೇಲೆ based ಆಗಿ ನೋಡಿದಾಗ charge it is observed that it is 0, and then mass of the neutron, it is observed to be 1.67 into 10 to the power minus 27 kg. Okay, so this both proton and neutron, they have approximately same mass. So now nucleus ಅನ್ನ ನೋಡಿದಾಗ nucleus ಅಲ್ಲಿ proton ಮತ್ತೆ neutron ಇರ್ತದೆ ಅಲ್ವಾ. So proton in a mass around 10 to the power 4 times greater than electron. ಅದೇ ರೀತಿ ನ್ಯೂಟ್ರಾನ್ ಇನ್ ಮಾಸ್ ಇಸ್ ಆಲ್ಸೋ 10 to the power 4 times greater than ಎಲೆಕ್ಟ್ರಾನ್. ಹಾಗಾಗಿ ಆ ನ್ಯೂಕ್ಲಿಯಸ್ ಅಲ್ಲಿ ಒಂದು ಕಾಂಪ್ಯಾಕ್ಟ್ ಸ್ಟ್ರಕ್ಚರ್ ಅಲ್ಲಿ ಪ್ರೋಟಾನ್ ಮತ್ತೆ ನ್ಯೂಟ್ರಾನ್ ಇರ್ತದೆ. ಸೊ ಅದರ ಮಾಸ್, when we say the mass of the atom, it is the complete mass of this proton, neutron ಮತ್ತೆ electron ಎಲ್ಲ ಸೇರಿ ಅದರ ಮಾಸ್ ಆಗ್ತದೆ ಅಲ್ವಾ. ಸೊ ಅದರಲ್ಲಿ ಈಗ ಮೇಜರ್ ಮಾಸ್ ಇಸ್ ಕ್ಯಾರಿಡ್ ಬೈ ವಿಚ್ ಸ್ಪೀಶೀಸ್? ಡೆಫಿನೆಟ್ಲಿ by looking at the values we can say that it is by the proton and the neutron. ಅದಕ್ಕೆ ನಾವೇನ್ ಹೇಳ್ತೇವೆ ಹೇಳಿದ್ರೆ electron in a mass is very negligible, and its mass of the atom is completely concentrated at the center, the nucleus ಅಂತ ಹೇಳೋದು ಆ ರೀಸನ್ ಇಂದ. Okay, so this is about the subatomic particles. So now subatomic particles ಅನ್ನು ನೋಡಿದ ನಂತರ we have discussed about the different types of the atomic species. ಅಲ್ವಾ, ಬೇರೆ ಬೇರೆ ಟರ್ಮಿನಾಲಜೀಸ್ that we frequently use, ಅದನ್ನ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡ್ತೇವೆ. ಸೊ ಅದರಲ್ಲಿ ಬರುವಂತಹ ಕೆಲವು ಟರ್ಮಿನಾಲಜೀಸ್ ಅನ್ನ ಲೆಟ್ ಅಸ್ ಸಿ. ಸೊ ಒನ್ ಇಸ್ ಐಸೋಟೋಪ್. ದಿಸ್ ಇಸ್ ವೆರಿ ಫೆಮಿಲಿಯರ್ ಟು ಯು ಅಲ್ವಾ. ಸೊ ವಾಟ್ ಆರ್ ಐಸೋಟೋಪ್ಸ್? Isotopes are the species which have same atomic number but different mass number. Alpha. So they have same atomic number but different mass number. For example, 1H1 irbodu, 1H2 irbodu, 1H3 irbodu. So all have, what is some atomic number? It is 1 here, 1 here and 1 here. So all have same atomic number. But mass number anta helidrenu, it is the sum of proton matte neutron number. And what is atomic number? Atomic number anta helidre adu neutron in number. So, atomic number ಹೇಳಿದ್ರೆ proton in number. So atomic number ಗಳು same ಇರ್ತದೆ ಅಲ್ವಾ? So all these three species have proton. How many protons? One proton. ಅಲ್ವಾ? So they have same atomic number, but mass number will be different. So in protium it is 1, in deuterium it is 2, and in tritium it is 3. ಅದರ ಅರ್ಥ ಏನು? protium ಅಲ್ಲಿ there is only one proton and no neutron. Deuterium ಅಲ್ಲಿ there is one proton and one neutron. So the total mass number will be 2. Alpha. And in tritium it is one proton number and 2 neutron number. So total sum will be 1 plus 2, it is 3. So the mass number will be 3. Okay, so such species which have same atomic number but differ in mass number is called as isotope. And then we come across isobars. So these are the species with same mass number. Okay, nodi mass number it is same but different atomic number. So what does it mean? Adra proton number galu bere bere, atomic number is different but they have same mass number. That is sum of proton and neutron number, that is same. Okay, so 18 argon 40 and 19 potassium 40. Both have same mass number. Sum of proton and neutron number, it is the same, 40. Whereas atomic number, if you look at, in argon, it is 18. Whereas in 19 potassium, it is 19. Okay, so such species which have same mass number but differ in atomic number is called as isobars. Okay. Next terminology that we come across is isotones. So what are these isotones? They are the species having same neutron, same number of neutrons. Okay, so say 1H3 and 2He4. So what is the number of neutron here? 3 minus 1, it is 2. And in helium 2He4, 4 minus 2, again it is 2. So species which have same number of neutrons are called as isotones. Next, one more terminology that we frequently use is isodiphers. So what are they? They have same difference of the number of neutrons and protons. So such species are called as isodiphers. They have same difference of the number of neutrons and protons. Okay, so for example, 19K39, potassium 39 element, and 9 fluorine 19. If you look at the difference of number of neutrons and protons. So number of proton here it is 19, and number of neutron, if you calculate 39 minus 19, so how much it will be? 20, right? 19 proton it has and 20 neutron it has. Okay, so 20 minus 19, how much it is? 1. And if you look at here, 9 fluorine, 9 atomic number, so proton number is 9. And what is the number of neutrons? 19 minus 9, it is 10. Okay, so neutron number is 10. So 10 minus 9, 1. So here also the difference between neutron and proton, it is 1. And in this species also the difference between neutron and proton, it is 1. So such species which have same difference of the number of neutrons and proton is called as isodiphers. Clear? Yes. And later we have discussed about the atomic models. So various scientists, they try to explain the structure of atom ಅಲ್ವಾ. ಫಸ್ಟಿಗೆ ಡಾಲ್ಟನ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ್ದು ಅದರಲ್ಲಿ indestructible ಅಂತ ಹೇಳಿದ್ರು. ಆ ನಂತರ later the experiments revealed that no, it has subatomic particles in it ಅಂತ ಹೇಳಿದ್ರು. So based on that, few other scientists also tried to explain the structure of atom. So ಅದರಲ್ಲಿ one of the first attempt was made by Thomson, and he has given his model as Thomson's model of an atom. So what he said, as per his model, atom is a sphere of positive charges uniformly distributed with the electrons. So it is, so what he said atom as a sphere. Okay, it is just a sphere with positive charges uniformly distributed in this sphere, with electrons scattered as points in the sphere, like we have that resins on the cake, no? Similarly, these electrons are distributed. Okay, randomly they are distributed. He explained the structure of atom in that way. Okay, so as per him, atom is just a sphere with positive charges uniformly distributed, and then electrons are scattered as points on this sphere. Okay, it is also called as plum pudding model. Anantra, Rutherford tried. Okay, so he did this alpha particle scattering experiment, okay, in which alpha source was taken and it was then made to fall over a gold plate, a thin gold plate, and which is surrounded by a photographic plate. So based on the experimental observations, he observed that most of the particles, they pass through the foil, okay, undeflected. So what does it indicate? A ray is passing through the space without any deflection. That means, that says that there is no interfering species, interfering substance. There is no interference at all. So what does it mean? It means that most of the space in atom must be empty. Okay, and then there were some particles, there were some rays which were deflected to a small angle. That indicates that these alpha particles, when we say, they will be positively charged. Okay, so when they are passing, if some of the rays are deflecting, that means that if they are changing its path to small angle, that means that there must be some kind of ಒಂದು ತಡೆ. There should be some kind of particle or something, okay, through which it cannot go. It is changing its path to a small angle. That means that this alpha particle also carries positive charge, and if it is getting deflected, that means that that center or that disturbance must also be carrying positive charge. Alpha. So that indicates that there is something positively charged center. And very few particles, they deflected nearly at 180 degree, indicating that positively charged solid thing, which is called as nucleus, is very, very, very small. There must be some very, very strongly, very solid positive charged species must be there at the center. Okay, the particles which bombard it, which come in a direct contact with it, okay, face to face with it, it just gets deflected to 180 degree, and which come very near to it, very close to it, they get deflected. ಅಲ್ವಾ. ಏನಾಗ್ತದೆ, ಈಗ ನಾವು ಸಪೋಸ್ ಇಫ್ ವಿ ಆರ್ ಟ್ರಾವೆಲಿಂಗ್ NH, ನಮ್ಮ ಎದುರು ಏನೋ ಒಂದು ವೆಹಿಕಲ್ ಇದೆ ಅಂತಂದ್ರೆ, ಇಫ್ we and that vehicle, if it is moving in the same direction, ನಾವು ನಮ್ಮ ಎದುರಲ್ಲಿ ಆ ವೆಹಿಕಲ್ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ನಾವು ಸಣ್ಣ ಡಿಫ್ಲೆಕ್ಷನ್ ಅನ್ನು ತಗೊಳ್ತೇವೆ ಅಲ್ವಾ. ಅದೇ ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ನಮ್ಗೆ ಬಂದ್ರೆ ಏನಾಗ್ತದೆ, ಎರಡು ಠಕ್ ಅಂತ ಗುದ್ದಿ ಬಿಡ್ತದೆ. ಓಕೆ, ಸೊ ಆ ರೀತಿ, ಓಕೆ, ಇಫ್ ದೇ ಕನ್ಫ್ರಂಟ್ ಫೇಸ್ ಟು ಫೇಸ್, ದೇ ಗೆಟ್ ಡಿಫ್ಲೆಕ್ಟೆಡ್, ಅಂಡ್ ಇಫ್ ಅಲ್ಲಿ ಸ್ಲೈಟ್ ನಿಯರ್ ಬಂದ್ರೆ ಅದು ಸಣ್ಣದಾಗಿ ಡಿಫ್ಲೆಕ್ಟ್ ಆಗಿ ಆ ಕಡೆ ಹೋಗ್ತದೆ. Okay, so what is this experiment? What does this reveal? It reveals that in the atom there must be the whole mass. Okay, it should be concentrated at the center of the atom, and it should carry the positive charge. Okay, and then electrons must be revolving around this nucleus. Okay, so electrons present in the empty space and they revolve around with a very high speed. So these are the observations and the conclusions of Rutherford's atomic model. So based on Rutherford ಏನು ಹೇಳ್ತಾನೆ, atom central ಇರ್ತದೆ, ಅದರಲ್ಲಿ centrally nucleus ಇರ್ತದೆ, ಆ nucleus ಅಲ್ಲಿ proton and neutrons, they will be concentrated at the nucleus, and whole mass of the atom is concentrated in the nucleus itself, and it is surrounded by the electrons at various radius, and these electrons will be revolving around the nucleus ಅಂತ ಹೇಳ್ತಾರೆ. Okay, so this is about the Rutherford atomic model. And later again, all these theories, they had some limitations associated with it, because later experiments were not able to, I mean, using this particular model, they were not able to explain the observations of some other experiments which were carried out later. Okay, and so, and there was also so all these observations or all these models, what does it say? It says about the particle nature of the atom. Okay, so later some more experiments were carried out which is based on this electromagnetic radiations. So which based on these experiments, the further fine structure of atom was developed, which led to the discovery, or which led to the proposal of this quantum theory, etc. Okay, whatever. So before this quantum theory, what are the experiments that led for the development of this quantum theory? Let us briefly go through. So one of the concept that developed was electromagnetic radiation theory, or this concept was developed. So what is this electromagnetic radiation, or what is this electromagnetic radiation? So electromagnetic radiation, okay, so light anta ನಾವು ಹೇಳ್ತೇವೆ. What is light? Light ಅಂದ್ರೇನು? Light ಅಂತ ಹೇಳಿದ್ರೆ it is nothing but electric and magnetic field which is moving in the form of a wave. Okay, now visible light anta ಏನು ಹೇಳ್ತೇವೆ ನೋಡಿ, it is nothing but electric and magnetic field which is moving in the form of wave. So that anything, a disturbance that moves, electric and magnetic field that moves in the form of wave is called as electromagnetic radiation. Okay, but we have like visible radiation, we have like ultraviolet radiation, we have X-rays, etc. So how they are different? They are different by their frequency, their velocity, their amplitude, their wavelength, their wave number, etc. So every wave, it is characterized by its wavelength, its frequency, its velocity, amplitude and wave number. ಈ ಪಾರ್ಟ್ ಇಂದ ಜಾಸ್ತಿ ಪ್ರಾಬ್ಲಮ್ಸ್ಗಳು ಬರ್ತವೆ. ನಮ್ಮ CET ಇರ್ಬೋದು, ನೀಟ್ ಇರ್ಬೋದು, JEE ಇರ್ಬೋದು. ಸೊ ಯು ಶುಡ್ ಬಿ ವೆರಿ ಥರೋ ವಿತ್ ದಿಸ್ ಪಾರ್ಟ್. Okay, ಇದು ನಿಮ್ಮ ಮೈಂಡ್ ಅಲ್ಲಿ ಕರೆಕ್ಟ್ ಆಗಿರಬೇಕು. Okay, so each wave, electromagnetic radiation has its own wavelength which is represented as lambda, and it has its own frequency nu, velocity c, and amplitude and wave number. What is a wavelength? Wavelength anta helidrenu, it is the distance between two successive crests. When we say wave, how does it look like? It looks like something like this, salva. Okay, so this upper part is called as a crest and the lower part is called as a trough. So the distance between these two successive crests, these successive troughs, it is called as a wavelength, and it is designated by lambda. And then what? One more term, one more characteristics that is associated with the wave is called as a frequency. So what is frequency? It is a number of waves which pass through a particular point in 1 second. It is called as a frequency. Okay, it has the velocity hertz, cycles per second. It is also called as the hertz. And velocity, you are well aware, in physics you come across. And then amplitude means it is a distance from the mean position. Okay, the highest distance from the mean position is called as a amplitude. And then one more number one more terminology that we come across is the wave number. It is represented as u bar. Idu kuda nimge gotte ide. It is a number of wavelengths per meter is called as a wave number of a centimeter. Okay, this is about the electromagnetic radiation. So what is the relationship there? It is c, velocity will be equal to lambda into nu, ಅಥವಾ in general ನಾವು ಹೆಚ್ಚಾಗಿ ನೆನಪಿಟ್ಕೊಳ್ಳೋದು ಇದನ್ನ, nu is equal to, that is frequency is equal to c by lambda. Okay, nu is equal to c by lambda. Velocity divided by velocity of light. Usually electromagnetic radiations, all the electromagnetic radiations, they have the speed of light. But when it enters into some medium, its speed may get altered. Okay, so nu is equal to c by lambda. This is one very important equation that we should know. And one more is, what is the relationship between wave number and the wavelength? It will be 1 by wave lambda will be equal to nu bar. Okay, and therefore we can also say that nu is equal to c into nu bar. So idra mele based agi ಹೆಚ್ಚಿನ problems galu irtave. Okay, nu is equal to c by lambda, 1 by lambda is equal to nu bar, anantara nu is equal to, therefore this equation can also be written as nu is equal to c into nu bar. Okay, and then two more theories or two more observations. Okay, two more experiments were carried out, and two more theories were developed. Okay, one is the Planck's quantum theory and the other one is the black body radiation. Okay, so this black body radiation, when we say black body anta helidre, a body which can emit all types of radiations. So such body which can emit or which can absorb all kinds of radiation is called as a black body. So when these radiations emitted by the black body, when it is observed, it is found that the electromagnetic so this black body, as the temperature increases, the certain frequency emitted by the black body, it will increase. Okay, so something like this. Okay, so the radiations emitted by the black body, if we look at the one particular frequency, it will be emitted to a large extent, and on other side, on either side of it, there is a decrease. Okay, and as the temperature increases, the frequency or this wavelength, wavelength also, this is intensity. So if we plot intensity versus lambda of this radiations emitted by the black body, if we observe at two different temperature, it looks something like this. Okay, so the frequency will shift to higher radiation field, higher frequency range, or wavelength will lower wavelength region, that. Okay, so this is about the black body. And later, one more theory that was proposed is the Planck's quantum theory. So as per Planck's quantum theory, this again, Planck's quantum theory, it is based on the photoelectric effect. Okay, so as per Planck's quantum theory, I'll come to that later. So before that, let me go through this photoelectric effect. Okay, so photoelectric effect, if we look at, it is nothing but, the name itself is suggesting you, photoelectric effect. Andre enu, when a photon strikes a metal, okay, electron will be ejected. Okay, so ejection of electrons from a metal surface when a light of certain frequency strikes on the surface is called as photoelectric effect. Photon metal na mele biddaga a metal na surface inda electron eject ಆಗ್ತದೆ ನೋಡಿ, that is called as photoelectric effect. Photon striking the metal surface giving electrons. Okay, it is called as photoelectric effect. Again, idu ashte, any frequency strike adaga metal mele, any photon strike adaga, it need not eject electron. Okay, it will require certain minimum frequency to knock out the electron from the metal surface, and that minimum frequency needed is called as the threshold frequency. And similarly, the number of ejected electron, it is observed that it is proportional to the intensity of the incident light. Okay, if the incident light is more intense, more number of electrons will be ejected. And the Einstein gave a photoelectric equation. So as per Einstein photoelectric equation, it is h nu is equal to h nu naught plus half mv square. So h nu is the energy of the incident photon. H is Planck's constant. Value is 6.626 into 10 to the power minus 34 joule second. Alpha, and nu is the frequency of the incident light. H nu naught, it is the H again Planck's constant. Nu naught is that minimum frequency that is needed for the ejection of electron, that is called as threshold frequency. And m is the mass of the electron that is ejected, and v is the velocity of the electron ejected, or this accounts for the kinetic energy associated with the ejected electron, and this accounts for actually the potential energy. Okay, so that minimum energy required to eject an electron from the surface is called as the work function. Idu ashte very careful. Idu equation mele based agi kuda many questions have been asked. So in the CET and the NEET exams. Okay, h nu is equal to h nu naught plus half m v square. Appa half m naught v square, where m is the mass of the electron ejected from the surface. Clear? Yes. Nantra, so based on these two, yaudu ನಮ್ಮ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಫೆಕ್ಟ್ ಮತ್ತೆ ಬ್ಲಾಕ್ ಬಾಡಿ ರೇಡಿಯೇಷನ್ ಮೇಲೆ ಬೇಸ್ಡ್ ಆಗಿ Planck's quantum theory was developed. So according to Planck's quantum theory, radiant energy which is emitted or absorbed will be in the form of a small discrete packets of energy known as quanta. So energy anta heluvanthadu adu ಒಂದು ಪ್ಯಾಕೆಟ್ ತರ ಇರ್ತದೆ, ಪ್ಯಾಕೆಟ್ ಆಫ್ ಎನರ್ಜಿ ತರ ಇರ್ತದೆ, ಒಂದು ಡಿಸ್ಕ್ರೀಟ್ ಕ್ವಾಂಟದ ಹಾಗೆ ಇರ್ತದೆ, and that is known as the quanta. The discrete packets of energy, it is known as the quantum. Okay, or in case of light it is called as the photon. So and the energy of the photon, every photon, it is equal to h e equal to h nu, or e is equal to h c by nu is equal to c by lambda alpha. So h is equal, e is equal to h c by lambda, where h is the Planck's constant and e is the energy of the photon or the quantum. So this theory was developed later. And then so when the radiations were observed, when various electromagnetic radiations were observed, it is seen that these various radiations can be arranged in the form of they can be arranged in the increasing order of its wavelength or decreasing order of its wavelength. So that is called as a spectrum. Okay, so when we arrange the various radiations in the increasing order of its wavelength, okay, it is called as the spectrum. Okay, now we are class alli ಏನು ಮಾಡ್ತೇವೆ, ಎಸ್ಪೆಷಲಿ ಇನ್ ದ ಲೋವರ್ ಕ್ಲಾಸಸ್, ಎಲ್ಲ ಮಕ್ಕಳನ್ನ ಬೆಂಚಲ್ಲಿ ಕೂತ್ಕೊಳ್ಳಿಸುವಾಗ ಹೌ ಡು ವಿ ಅರೇಂಜ್ ದೆಮ್ ಬೇಸ್ಡ್ ಆನ್ ದೇರ್ ಹೈಟ್ ಅಲ್ವಾ, ಹೈಟ್ ಮೇಲೆ ಬೇಸ್ಡ್ ಆಗಿ ಅವರನ್ನ ಕೂತ್ಕೊಳ್ಳಿಸ್ತೇವೆ. ಅದೇ ರೀತಿ ವೆನ್ ದಿಸ್ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ರೇಡಿಯೇಷನ್ಸ್ ಆರ್ ಅರೇಂಜ್ಡ್ ಇನ್ ದ ಇನ್ಕ್ರೀಸಿಂಗ್ ಆರ್ಡರ್ ಆಫ್ ಇಟ್ಸ್ ವೇವ್ ಲೆಂತ್, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್ ಎವರ್ ವಿ ಗೆಟ್, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಅ ಸ್ಪೆಕ್ಟ್ರಮ್. ಸೊ ದಿಸ್ ಸ್ಪೆಕ್ಟ್ರಮ್ ಕೆನ್ ಬಿ ಎಮಿಷನ್ ಸ್ಪೆಕ್ಟ್ರಾ ಅಥವಾ absorption spectra ಅಂತ ಹೇಳ್ತೇವೆ. So atomic spectra, when the radiation emitted by an atom, when it is observed, it is called as a atomic spectrum. Again, this atomic spectrum can be emission spectrum or absorption spectrum. So if the spectrum is obtained, the various radiations are obtained when the radiation, when we observe that radiation, when that spectra arises because of the emission of radiation by the substance, then it is called as a emission spectrum. On the other hand, if it is because of the absorption of energy, then it is called as a absorption spectrum. So we can have two types of spectrum there, emission spectra or absorption spectrum. If the spectrum is obtained by the radiations emitted by the substance, it is called as emission spectra. On the other hand, if the spectrum is obtained by the absorption of radiation, then it is called as a absorption spectrum. Okay, so idralli first agi hydrogen, because simplest atom is the hydrogen. No complications there because there is only one electron and one proton. There is no neutron. So interference also very less because there is only one electron ಆಗಿರೋದ್ರಿಂದ. Okay, so hydrogen anna it is studied very deeply, and other spectra whatever it is obtained, it is called as a line spectrum of hydrogen. Line spectra ಯಾಕೆ ಅಂತ ಹೇಳಿದ್ರೆ it is in the spectrum when we arrange, it is like in the form of a line. Again spectravana adra picture ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿ we can have band spectra. So band spectra ಅಂತ ಹೇಳಿದ್ರೆ ಅಲ್ಲಿ ಹತ್ರ ಇರ್ತದೆ ಲೈನ್ಗಳು. Okay, so it appears as if there is a band of radiations. Okay, and then there is a line spectra, and then there is a continuous spectra throughout very radiations idre that forms the continuous spectrum. Okay, band thara radiations namge ಕಂಡ್ರೆ when we take the picture of that. Okay, and if it appears as a band, one band, ಎರಡು bands, I mean third band like that, if it appears like that, then it is called as the band spectra. Or if it appears as like a line, okay, distinct lines if we get, then it is called as a line spectrum. Okay, so this classification, it is based on the picture of the spectrum. Okay, so for hydrogen it is a line spectrum is observed. Okay, and this line spectrum was studied, and it is observed that the frequency idra mele based agi sa ashte very important, idra mele based agi ಬೇರೆ ತುಂಬಾ ಪ್ರಾಬ್ಲಮ್ಸ್ ಗಳನ್ನ ನಾವು ನೋಡ್ತೇವೆ. Okay, so nu bar, I mean what is nu bar? It is a wave number. Wave number is equal to, so how does the spectrum arises? Basically spectrum ಯಾಕೆ arise ಆಗ್ತದೆ ಹೇಳಿದ್ರೆ, when an electron, for when basically electron, when an electron jumps from one level to other level. In the Rutherford atomic model we have seen, okay, it is arranged in various atomic orbitals. The electron will be arranged in, electron will be revolving around the nucleus. ಅಥವಾ ನಮ್ಮ ಬೋರ್ ಮಾಡೆಲ್ ಅಲ್ಲೂ ಅಷ್ಟೇ, ಇಟ್ ಇಸ್ ರಿವಾಲ್ವಿಂಗ್ ಅರೌಂಡ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್ ಅಟ್ ಇನ್ ಡಿಫ್ರೆಂಟ್ ಆರ್ಬಿಟ್ಸ್ ಅಂತ ಹೇಳ್ತೇವೆ, ಡಿಫ್ರೆಂಟ್ ಎನರ್ಜಿ ಲೆವೆಲ್ಸ್ ಅಂತ ಹೇಳ್ತೇವೆ ಅಲ್ವಾ. ಸೊ ಒಂದು ಎನರ್ಜಿ ಲೆವೆಲ್ ಇಂದ ಇನ್ನೊಂದು ಎನರ್ಜಿ ಲೆವೆಲ್ಗೆ ಜಂಪ್ ಆಗುವಾಗ ಇಟ್ ಮೇ ಎಮಿಟ್ or it may absorb radiation. If it is moving from lower energy level to higher energy level, it should absorb radiation. Then we get absorption spectrum. On the other hand, if it is jumping from higher energy level to lower energy level, then it will emit that extra energy. Then we get emission spectrum. Okay, so the radiations or the spectrums obtained by that phenomenon, it is studied, and a relation was drawn, and that is nu bar is equal to, so that relationship between wave number and the orbit, it is given by this equation. So nu bar is equal to 109,677 into 1 by n1 square minus 1 by n2 square. Sorry, this is n2 square per centimeter. This is called as a Rydberg constant. This constant, it is called as a Rydberg constant. Okay, so in the line spectrum, if we observe, various lines were seen. So it is called as Lyman series, Balmer series, Paschen series, Brackett series, and Fund series. So for Lyman series, it is obtained when an electron moves from n equal to 1 to n equal to 2, 3, 4, etc. Okay, so if we look at the various energy levels, okay, if this is n equal to 1, okay, then there will be n equal to the various orbits, various energy shells will be like this at different energy. So lowest energy will be the first shell, and it is n1, n2, n3, n4, etc. So various shells will be there, various energy levels will be there. So if electron jumps from say n equal to 2 to n equal to 1, or n equal to 3 to n equal to 1, or n equal to 4 to n equal to 1, then this Lyman series is obtained. Okay, and so obtained radiation, they fall under ultraviolet range. Okay, so namge ultraviolet range alli ee Lyman series sigtade. And similarly Balmer series, if we look at, it is obtained when the transition of electron occurs from n equal to 3, 4, etc. to n equal to 2. So second energy level ge transition adre from the higher energy level, then we get the Balmer series. So it comes in the visible range. And Paschen series is obtained when the transition occurs from n equal to 4, 5, etc. to n equal to third shell ಗೆ transition ಆದರೆ electron from 4th level, 5th level or 6th level, I mean higher level, then we obtain Paschen series and that comes under infrared range. ಅದೇ ರೀತಿ bracket series ಇದೆ. So bracket series ಅಲ್ಲಿ the transition will be from 5th, 6th or higher energy to the 4th level. Okay, it also comes under infrared range. Fund series, when the transition from higher energy level to 5th level, it is called as the Fund series and it comes under infrared range. So Lyman series ultraviolet range ಅಲ್ಲಿ ಬರ್ತದೆ, Balmer series visible range and the other three Paschen, bracket and Fund series comes under infrared range. ಇದು ಅಷ್ಟೇ, ಇದೊಂದು ಸ್ವಲ್ಪ ನೆನಪಿಟ್ಕೊಳ್ಬೇಕು. ಯಾಕೆ ಹೇಳಿದ್ರೆ ಅಲ್ಲಿ ಜಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಕೊಡುವಾಗ ಏನ್ ಹೇಳ್ತಾರೆ, a line is observed in the Balmer series ಅಂತ ಹೇಳ್ತಾರೆ. They will not mention what is a n1 value. Then you should know if it is Balmer series, if it is coming in the visible range, then n1 should be 2. Okay, it should be the Balmer series. Okay, so that you will be able to write the value of n1 here in the equation. ಅಥವಾ Lyman series ಅಂತ ಹೇಳಿದ್ರು. Okay, ಅಥವಾ simple ಆಗಿ they may say it is the spectrum is obtained in the ultraviolet range ಅಂತ ಹೇಳಿದ ತಕ್ಷಣ it should come to your mind that it is Lyman series and the value of n1 is 1. Okay, so Lyman series, Balmer series, ultraviolet ಮತ್ತೆ visible range ಅಲ್ಲಿ ಬಾಕಿದೆಲ್ಲವೂ ಕೂಡ infrared range ಅಲ್ಲಿ. Okay, n1 value 1 ಇರ್ತದೆ Lyman ಗೆ, Balmer ಗೆ 2, Paschen ಗೆ 3, bracket ಗೆ 4 and for the Fund series it is 5. Okay, so based on this Bohr proposed his model of hydrogen. So ಅವನು ಏನ್ ಹೇಳ್ತಾನೆ, electrons will be revolving around the nucleus only in stationary path of fixed radius and energy and it is called as a orbit ಅಥವಾ shell. Okay, and energy of this orbit does not change with time. The energy of the orbit will be the same. Okay, but energy when there is a transition occurs from or when an electron jumps from higher energy to lower energy or lower energy to higher energy, then the energy will be emitted or absorbed. Okay, and then angular momentum of the electron, it is the integral multiple. Okay. Integral multiple of h by 2 pi, so that it is angular momentum of the electron, it is quantized, he said, and it is given by mvr equal to nh by 2 pi, where m is the mass of the electron, v is the velocity with which it is moving, revolving around the nucleus, r is the radius or the distance from the nucleus to that orbit. Okay, and n, it is integer like 1, 2, 3, etc. It is basically nothing but the energy level, first shell, second shell, third shell, etc. Okay, h ಅಂತ ಹೇಳಿದ್ರೆ Planck's constant and 2 pi ಗೊತ್ತಿದೆ, it is a constant. Okay, frequency of radiation absorbed or emitted nu is given by delta E by h ಅಥವಾ E2 minus E1 by h. Another radius of the orbit, it is given by 52.9 into n square. Remember, this is for hydrogen or hydrogen like species. So hydrogen like species ಅಂತ ಹೇಳಿದ್ರೆ ಏನು, hydrogen like species ಅಂತ ಹೇಳಿದ್ರೆ which has one electron only. For example, helium plus ಅಥವಾ lithium plus 2, ಅದೆಲ್ಲ hydrogen like species. So ಅದರಲ್ಲೆಲ್ಲ radius of the nth orbit will be 52.9 into n square divided by z, where z is the atomic number of the element. Hydrogenic ಆದಾಗ it will be 1. ಇದು ಕೂಡ ಅಷ್ಟೇ, remember this is a very 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 important formula. R naught is equal to 52.9 into n square divided by z. Okay, ನಂತರ energy of the electron in the nth orbit, it is given by minus 2.18 into 10 to the power minus 18 into z square by n square. Again ಇದು ಕೂಡ ಅಷ್ಟೇ hydrogen like species ಗೆ. Okay, so z square by n square 2.18 into 10 to the power minus 18 into z square divided by n square. Okay, again this is a constant. RH, Rydberg constant, in terms of joules. Okay, and similarly, when the transition occurs, delta E, it is minus 2.18 into 10 to the power minus 18 into 1 by n1 square minus 1 by n2 square into z square. Okay, so n ಮತ್ತೆ z ಅದು ಯಾವತ್ತು ಏನು ಆಪೋಸಿಟ್ ಇದರಲ್ಲೇ ಬರ್ತದೆ. ನ್ಯೂಮರೇಟರ್ ಅಲ್ಲಿ n ಇದ್ರೆ ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ z ಇರ್ತದೆ. n ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ ಇದ್ರೆ z will be in the numerator. That you should keep it in your mind. Okay, ಸೊ ಇಲ್ಲಿ ನೋಡಿ, and one more relationship, ಇಲ್ಲಿ ಮಾತ್ರ ನಿಮಗೆ ರೇಡಿಯಲ್ಲಿ ಮಾತ್ರ it is n square divided by z, whereas in all other terms it is z square only. Okay, so this also you keep in your mind. Okay, and velocity of an electron in the nth orbit, it is given by Vn is equal to V naught into z divided by n. Okay. Where V naught is again 2.18 into 10 to the power 8 centimeter per second. So based on these observations, a dual behavior of matter was proposed. Okay, dual behavior anta helidre, it can behave both like particle as well as wave anta heli. Okay, so de Broglie proposed a theory. So as per de Broglie's theory, moving particle behave both like wave as well as matter. ನಮ್ಮ ನೋಡಿ, ನಮ್ಮ ಕ್ಲಾಸಿಕಲ್ ಥಿಯರಿ ಪ್ರಕಾರ, ಕ್ಲಾಸಿಕಲ್ ಥಿಯರಿ ಅಂತ ಹೇಳಿದ್ರೆ ಏನು, ನಮ್ಮ ನ್ಯೂಟನ್ಸ್ ಥಿಯರಿ, ನೀವು ಮೋಷನ್ಸ್, ಲಾ ಆಫ್ ಮೋಷನ್ಸ್ ಎಲ್ಲ ನೋಡಿದಿರಿ ಇನ್ ಫಿಸಿಕ್ಸ್ ಅಲ್ವಾ. ಸೊ ಆಲ್ ದಟ್ ಕಮ್ಸ್ ಅಂಡರ್ ದ ಕ್ಲಾಸಿಕಲ್ ಥಿಯರಿ. ಯಾಕೆಂತ ಹೇಳಿದ್ರೆ ಆಲ್ ದಟ್ ಲಾಸ್ ಇಟ್ ಹೋಲ್ಡ್ ಗುಡ್ ಫಾರ್ ದ ಮ್ಯಾಕ್ರೋಸ್ಕೋಪಿಕ್ ಪಾರ್ಟಿಕಲ್. ಈಗ ನಮ್ಮ ವೆಲಾಸಿಟಿ ಅಥವಾ ಬಸ್ಸಿನ ವೆಲಾಸಿಟಿ ಅಥವಾ ಸೇ ಕಾರ್ ವೆಲಾಸಿಟಿ, ಕ್ಯಾಬ್ ವೆಲಾಸಿಟಿ, ಅದನ್ನೆಲ್ಲ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೋದು. ಎಕ್ಸಾಕ್ಟ್ ಲೊಕೇಶನ್ ಆಲ್ಸೋ ವಿ ಕ್ಯಾನ್ calculate. We'll come to know the exact location as well. Okay, so adella it is based on the classical theory. So Newtonian laws enide, it comes under the classical theory. Okay, so idu nama de Broglie principle, when the substance becomes a microscopic object like proton, electron, adella microscopic object. So a microscopic object galige ee classical theory will not hold good. Okay, so ಯಾಕೆ ಹೇಳಿದ್ರೆ, ಬಿಕಾಸ್ ದೀಸ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಬಿಹೇವ್ ಬೋತ್ ಲೈಕ್ ವೇವ್ ಅಂಡ್ ಮ್ಯಾಟರ್. ಮ್ಯಾಟರ್ ತರ ಸಹ ಬಿಹೇವ್ ಆಗ್ತದೆ, ವೇವ್ ತರ ಸಹ ಬಿಹೇವ್ ಆಗ್ತದೆ. ಸೊ ವಿ ಕಾಲ್ ಇಟ್ as it shows a dual behavior. So he has given a equation called as de Broglie equation. So as per this equation, the wavelength of wave associated with the moving particle is given by lambda is equal to h by mv, where mv is nothing but the momentum. So this lambda can also be written as h by p, where p is the momentum and h is the Planck's constant. Lambda ant helidre wavelength of the it is the wavelength of the wave associated with the moving particle. Okay, whenever a particle is moving, it will be moving in the form of wave. Electromagnetic radiation hege wave thara behave agtade, ade riti any moving particle will have this wave nature. In macroscopic object, this wave is not visible. We will not be able to make out the wave. Ade microscopic object ke hodaga that wave, it will also be of considerable effect. Okay, so ಅದರನ್ನ ನಾವು ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗುದಿಲ್ಲ. ಈಗ ಮೈಕ್ರೋಸ್ಕೋಪಿಕ್ ಆಬ್ಜೆಕ್ಟ್, ಈಗ ನಾವು ಕೂಡ ಮೂವ್ ಆಗುವಾಗ ಮೇ ಬಿ ವಿಲ್ ಬಿ ಮೂವಿಂಗ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ವೇವ್ ಓನ್ಲಿ, ಬಟ್ ಅದು ಅಂತ ಒಂದು ದೊಡ್ಡ ಚೇಂಜ್ ಅನ್ನ ಮಾಡುದಿಲ್ಲ. Okay, because the wavelength will be very, very, very small when compared to the mass of the object. ಅದೇ ಮೈಕ್ರೋಸ್ಕೋಪ್ ಆಬ್ಜೆಕ್ಟ್ ಗೆ ಹೋದಾಗ ಮಾಸ್ ಅಂಡ್ ದ wavelength it will be comparable. ಅದರಿಂದ it is very significant ಆಗ್ತದೆ. Okay, so wavelength is the wavelength of the wave associated with the particle, and p is the velocity of the particle, m ಅಂತ ಹೇಳಿದ್ರೆ mass of the particle, and p is the momentum of the momentum associated with the motion. Okay, so this classical theory, microscopic objectಗಳು ಕ್ಲಾಸಿಕ್ ಥಿಯರಿಯನ್ನ ಫಾಲೋ ಮಾಡದೇ ಇದ್ದದ್ರಿಂದ ಇನ್ನೊಂದು ಶ್ರಾಡಿಂಜರ್ ವೇವ್ ಈಕ್ವೇಶನ್ ಅಥವಾ ಕ್ವಾಂಟಮ್ ಮೆಕ್ಯಾನಿಕಲ್ ಮಾಡೆಲ್ ಬಂದದ್ದು ಅವಾಗ. Okay, so again, which favors for this quantum mechanical model is this dual behavior or de Broglie principle, and innondu it is the Heisenberg's uncertainty principle. So as per Heisenberg's uncertainty principle, it is not possible, it is impossible to determine at any given instant both the momentum and the position of subatomic particles. Subatomic particle antalla, even in the microscopic particle basically. Okay, it is not possible to determine the exact position and the momentum of the particle. Okay, exact position anta bandaga adu classical theory ge hogtade. ಆಯ್ತಾ, ಅದೇ ಮೊಮೆಂಟಮ್ ಅಂತ ಬಂದಾಗ ಎನಿ ಮೂವಿಂಗ್ ಆಬ್ಜೆಕ್ಟ್ ಹ್ಯಾಸ್ ದ ಮೊಮೆಂಟಮ್ ಅಸೋಸಿಯೇಟೆಡ್ ವಿತ್ ಇಟ್, ಕರೆಕ್ಟ್ ಅಲ್ಲ? ನೀವು ಇವನ್ ಫಿಸಿಕ್ಸ್ ಅಲ್ಲಿ ನೋಡ್ತೀರಿ, ಎನಿ ಮೂವಿಂಗ್ ಆಬ್ಜೆಕ್ಟ್ಗೆ ಇಟ್ ಹ್ಯಾಸ್ ಮೊಮೆಂಟಮ್ ಅಸೋಸಿಯೇಟೆಡ್ ವಿತ್ ಇಟ್ ಅಂತ ಹೇಳಿ. ಓಕೆ, ಸೊ ಈ ಮೊಮೆಂಟಮ್ ಪಾರ್ಟ್ ಅಂತ ಹೇಳುವಂಥದ್ದು ಹಾಗಾಗಿ ವೇವ್ ಪಾರ್ಟಿಕಲ್ಗೆ ಬರ್ತದೆ, ಮೂವಿಂಗ್ ಇಟ್ಗೆ ಬರ್ತದೆ. ಅದೇ ಎಕ್ಸಾಕ್ಟ್ ಪೊಸಿಷನ್ ಅಂತ ಹೇಳುವಂಥದ್ದು ನಮ್ಮ ಕ್ಲಾಸಿಕಲ್ ಮೆಕ್ಯಾನಿಕ್ಸ್ಗೆ ಬರ್ತದೆ. ಓಕೆ, ಸೊ as per Heisenberg's uncertainty principle, it is impossible to determine at any instant the momentum and the position of the particle. Okay, and he has given an equation. It is like this: delta x is equal to delta p, which will always be greater than or equal to h by 2 pi. Okay, so what is delta x? It is the error in athwa uncertainty in position. And what is delta p? It is the error in momentum or uncertainty in momentum. It is always greater than or equal to h by 4 pi. Okay, or and if we are substituting for momentum equation, we know m into v alpha. So delta p, uncertainty in momentum, will be delta m into v plus delta m into delta v. Adre change in mass, it is not a mass of the substance will remain constant, correct alla? Hagagi error in mass will be nil. Hagagi whatever error in momentum we get, it must be because of the error in velocity. Hagagi delta p will be basically, it will be equal to m into delta v ಆಗ್ತದೆ. So if we substitute this back in this equation, we get m equal to, so substitute for delta p this. So we will get m into delta v into delta x will be greater than or equal to h by 4 pi. Okay. Yes, so based on this, ಈ ಎರಡು ಥಿಯರೀಸ್ ಅನ್ನ, ಡ್ಯುಯಲ್ ಬಿಹೇವಿಯರ್ ಅನ್ನ ಮತ್ತೆ ಅನ್ಸರ್ಟನಿಟಿ ಪ್ರಿನ್ಸಿಪಲ್ ಅನ್ನ ಒಟ್ಟಿಗೆ ಮಾಡಿ, ಅದೇ ಕೆಲವು ಕ್ಲಾಸಿಕಲ್ ಥಿಯರಿಗಳನ್ನೆಲ್ಲ ಒಟ್ಟಿಗೆ ಮಾಡಿದಾಗ ನ್ಯೂ ಥಿಯರಿ ವಾಸ್ ಪ್ರಪೋಸ್ಡ್ ಅಂಡ್ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ದ ಕ್ವಾಂಟಮ್ ಮೆಕ್ಯಾನಿಕಲ್ ಮಾಡೆಲ್. ಕ್ವಾಂಟಮ್ ಮೆಕ್ಯಾನಿಕಲ್ ಮಾಡೆಲ್. ಸೊ ಕ್ವಾಂಟಮ್ ಮೆಕ್ಯಾನಿಕಲ್ ಮಾಡೆಲ್ ಅಲ್ಲಿ ಜಾಸ್ತಿ ವರ್ಕ್ ಮಾಡಿ ಜಾಸ್ತಿ, ಸೊ ಇದು ನಮ್ಮ ಮೈಕ್ರೋಸ್ಕೋಪಿಕ್ ಆಬ್ಜೆಕ್ಟ್ಸ್ಗಳ ಪ್ರಾಪರ್ಟಿಯನ್ನ ಎಲ್ಲ ಸ್ಟಡಿ ಮಾಡಿ ಪ್ರಪೋಸ್ ಮಾಡಿರುವಂತಹ ಥಿಯರಿ. ಓಕೆ, ಸೊ ಆಸ್ ಪರ್ ಕ್ವಾಂಟಮ್ ಮೆಕ್ಯಾನಿಕಲ್ ಮಾಡೆಲ್, ದ ವೇವ್, ದ ಎಲೆಕ್ಟ್ರಾನ್, ಇಟ್ ವಿಲ್ ಬಿ ಬಿಹೇವಿಂಗ್ ಬೋತ್ ಲೈಕ್ ಅ ಪಾರ್ಟಿಕಲ್ ಆಸ್ ವೆಲ್ ಆಸ್ ದ ವೇವ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಅಂಡ್ ಶ್ರಾಡಿಂಜರ್ ಹ್ಯಾಸ್ ದೇರ್ಫೋರ್ ಗಿವನ್ ಅ ಈಕ್ವೇಶನ್ ಫಾರ್, ಸೊ ಏನು ನಮ್ಮ ಬೋರ್ ಥಿಯರಿ ಪ್ರಕಾರ ಏನ್ ಹೇಳ್ತಾನೆ, ಸೆಂಟರ್ ಅಲ್ಲಿ ನ್ಯೂಕ್ಲಿಯಸ್ ಇರ್ತದೆ, and then this electron will be revolving around the nuclei in a fixed orbit at a fixed distance from the nuclei ಅಂತ ಹೇಳ್ತಾರೆ ಅಲ್ವಾ. ಸೊ ಕ್ವಾಂಟಮ್ ಮೆಕ್ಯಾನಿಕಲ್ ಅಲ್ಲಿ ಏನ್ ಹೇಳ್ತಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಈಗ ಇದು ಫಿಕ್ಸ್ಡ್ ಪಾತ್ ಅಲ್ಲಿ ಹೋಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ, we will be able to locate the position and the momentum at the same time. So what is this but uncertainty principle said it is not so. We will not be able to detect, in the case of electron, we will not be able to locate the exact position or the exact momentum at the same time. If we go for the location of the exact position, we will go wrong in calculation of momentum. And similarly, if we go for the exact calculation of the momentum, we will end up with a mistake in position, location. Okay, so adrindagi this quantum mechanical model anna propose ಮಾಡಿರುವಂತದ್ದು. Okay, or this theory was developed. So as per quantum mechanical model, what does he say is the electron will be revolving in the form of wave only. Okay, it has both wave nature as well as the particle nature. So it will be in a fixed radius. Even if we say it will not be fixed, it will be in the form of a wave. Okay, and this Schrodinger has given a wave equation of the electron in case of hydrogen, and it is h psi is equal to, that equation is h psi is equal to E psi, or it can also be written in this form, delta square, del square psi by del x square plus del square psi by del y square. In the three-dimensional equation it accounts for x direction, y direction, z direction. It takes into account all the 3 dimensions. So this is a 3-dimensional equation. for the motion of electron around the nucleus. ಈಗ ನೀವು ಏನು ಸ್ಟ್ರೈಟ್ ಲೈನ್ ಈಕ್ವೇಶನ್ ಬರೀತೀರಿ ಹೇಗೆ, ಇಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು y is equal to mx plus c. So when we say any okay, this equation y is equal to mx plus c. So when we say this is in the form of y is equal to mx plus c ಅಂತ ಹೇಳಿದ್ರೆ, then that it must be, the variation must be in the form of line ಅಂತ ಹೇಳ್ತೇವೆ ಅಲ್ವಾ. there should be a linear variation ಅಂತ ಹೇಳ್ತೇವೆ. ಸೊ ಆ ರೀತಿ ಈ ರೀತಿ ಈಕ್ವೇಶನ್ ಬಂತಂತ ಹೇಳಿದ ತಕ್ಷಣ it will come to our mind that it must be a line. ಅಥವಾ if it is a hyperbola, then it has certain equation associated with it. We can write a hyperbola, ಏನು any picture ಅನ್ನ for that matter we can write mathematically ಅಲ್ವಾ. ಸೊ ಲೈನ್ ಅನ್ನ we can write like this, y is equal to mx plus c ಅಂದ್ರೆ it is a line ಅಂತ ಆಗ್ತದೆ ಅಲ್ವಾ. ಅದೇ ರೀತಿ ಒಂದು ಸರ್ಕಲ್ಗೆ there is some mathematical equation. ಒಂದು ಪ್ಯಾರಾಬೋಲಾಗೆ, ಹೈಪರ್ಬೋಲಾಗೆ there is some mathematical equation. ಅದೇ ರೀತಿ ಮೂವ್ಮೆಂಟ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಅರೌಂಡ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್ ಅನ್ನ ನಾವು ಈಕ್ವೇಶನ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರೀಲಿಕ್ಕೆ ಆಗ್ತದೆ. Okay, and that is given by the Schrodinger, and it is called as Schrodinger wave equation. Okay, and it is like this. Okay, it accounts for the three-dimensional motion. It considers all the three dimensions. Okay, and it is equal to this plus 8 pi square m by h square into e minus u into psi equal to 0. It considers the potential energy as well as the kinetic energy part of the motion as well. Okay, or in general we can write it as h psi is equal to he psi, where h is called as the Hamiltonian operator ಅಂತ ಹೇಳ್ತೇವೆ. ಓಕೆ, ಇದು ಬೇಸಿಕಲಿ ಇದೇನಂತ ಹೇಳಿದ್ರೆ ಒಂದು ಈಕ್ವೇಶನ್ ಅಷ್ಟೇ. ಆಸ್ ಸಚ್ ನಾವು ಈಕ್ವೇಶನ್ ಅನ್ನ y ಈಕ್ವಲ್ ಟು mx ಪ್ಲಸ್ ಸಿ ಅಂತ ಹೇಳಿದಾಗ ನಮಗೆ ಏನಾದ್ರೂ ಅರ್ಥ ಗೊತ್ತಾಗ್ತದ? ಇಟ್ ಹ್ಯಾಸ್ ಎನಿ ಸಿಗ್ನಿಫಿಕೆನ್ಸ್? ಏನಾದ್ರೂ ಫಿಸಿಕಲ್ ಸಿಗ್ನಿಫಿಕೆನ್ಸ್ ನಮ್ಗೆ ಗೊತ್ತಾಗ್ತದ? ಇಲ್ಲ. Okay, when we go deep into that, we will come to know the physical significance ಅಥವಾ physical meaning of that. y equal to mx plus c ಅಂತ ಹೇಳಿದ್ರೆ ಅದು ಲೈನ್. ಸಿ ವ್ಯಾಲ್ಯೂ ನೋಡ್ಕೊಂಡು ಇದು ಇಲ್ಲಿಂದ ಪಾಸ್ ಆಗ್ತದೆ, ಇದು ನೆಗೆಟಿವ್ ಸ್ಲೋಪ್ ಇದೆ, ಇದು ಪಾಸಿಟಿವ್ ಸ್ಲೋಪ್ ಇದೆ ಅಂತ ಹೇಳುವಂಥದ್ದು. ವೆನ್ ವಿ ಲುಕ್ ಎಟ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎಂ ಅಂಡ್ ಸಿ ವಿ ವಿಲ್ ಗೆಟ್ ಟು ನೋ, ರೈಟ್? ಅದೇ ರೀತಿ ಇಲ್ಲಿ ಕೂಡ ಅಷ್ಟೇ, ಸೈ ಅಂತ ಹೇಳಿದ್ರೆ ಅದಕ್ಕೆ ಏನು ಮೀನಿಂಗ್ ಇಲ್ಲ, ಇಟ್ ಹ್ಯಾಸ್ ನೋ ಫಿಸಿಕಲ್ ಸಿಗ್ನಿಫಿಕೆನ್ಸ್. ಓಕೆ, ಅಂಡ್ ಹೆಚ್ ಅಂತ ಹೇಳಿದ್ರೆ ಇಟ್ ಇಸ್ ಅ ಆಪರೇಟರ್ ಅಷ್ಟೇ, ಲೈಕ್ ಅಡಿಷನ್ ಮಾಡಬೇಕು, ಸಬ್ಟ್ರಾಕ್ಷನ್ ಮಾಡಬೇಕು. ಓಕೆ, ಲೈಕ್ ದಟ್, ಇಟ್ ಇಸ್ ಜಸ್ಟ್ ಅ ಆಪರೇಟರ್. Okay, psi is a wave function or equation. Okay, m is mass of the electron, E is the permissible total energy of the electron, U is the potential energy of the electron. It is equal to minus t square by r. Don't worry, ಇದರ ಮೇಲೆ ಬೇಸ್ಡ್ ಆಗಿ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಂತದೇನು ಇರುವುದಿಲ್ಲ. H is equal to Planck's constant. Okay, and now based on this equation the orbitals were explained later. So what is orbit ಅಂತ ಹೇಳಿದ್ರೆ, keep your mind, ಆರ್ಬಿಟ್ ಅಂತ ಹೇಳಿದ್ರೆ ಅದು ಮೇನ್ ಎನರ್ಜಿ ಲೆವೆಲ್. ಬಟ್ ಆರ್ಬಿಟಲ್ ಅಂತ ಹೇಳಿದ್ರೆ ಯಾವ ಶೇಪ್ ಅಲ್ಲಿ ಇದೆ ಆ ಮೇನ್ ಎನರ್ಜಿ ಲೆವೆಲ್ ಅಲ್ಲಿ. ಅದ ಆರ್ಬಿಟ್ ಅಂತ ಹೇಳಿದ್ರೆ ಬೇಸಿಕಲಿ ಏನ್ ಹೇಳಿ, ಇಟ್ ಈಸ್ ಅ ಪಾತ್ ಇನ್ ವಿಚ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ವಿಲ್ ಬಿ ಮೂವಿಂಗ್ ಅರೌಂಡ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್. ಇಟ್ ನೀಡ್ ನಾಟ್ ಮೂವ್ ಇನ್ ವೆನ್ ವಿ ಸೇ ಸ್ಟೂಡೆಂಟ್ ಇನ್ ಕ್ಲಾಸ್ ಸ್ಟಾಫ್ ರೂಮಿಗೆ ಹೋಗು ಅಂತ ಹೇಳಿದ ತಕ್ಷಣ ಅವ ಸ್ಟ್ರೈಟ್ ಆಗಿ ಸ್ಟಾಫ್ ರೂಮಿಗೆ ಹೋಗ್ಬೋದು, ಅವ ಇಡೀ ಬಿಲ್ಡಿಂಗಿಗೆ ಸುತ್ತಾಕಿ ಸ್ಟಾಫ್ ರೂಮಿಗೆ ಹೋಗ್ಬೋದು ಅಲ್ವಾ. there is various possibility. ಅದೇ ರೀತಿ when we say orbit ಅಂತ ಹೇಳಿದ್ರೆ ಅದು main energy level ಆಯ್ತಾ. ಸೊ ಅದರಲ್ಲಿ it can move in a circular fashion. The electron may be moving in a this dumbbell shape, it may be moving in a double dumbbell shape. Okay, so these are called as a orbital. Okay, orbit ಅಂತ ಹೇಳಿದ್ರೆ ಅದು main energy level. Orbital ಅಂತ ಹೇಳಿದ್ರೆ the exact way in which it is moving, it is orbitals, or it is also called as a sub energy levels ಅಥವಾ sub shells ಅಂತ ನಾವು ಹೇಳ್ತೇವೆ. Okay, so orbital wave function psi has no significance, but psi square measures the electron probability density at a given point. Probability density ಏನು, whether the electron exists or not at a particular point ಅಂತ ಹೇಳುವಂಥದ್ದನ್ನ psi square ಹೇಳ್ತದೆ. psi ಅಂತ ಹೇಳಿದ್ರೆ ಜಸ್ಟ್ ಈಕ್ವೇಶನ್, ಅದಕ್ಕೆ ಏನೇ it has no physical meaning. Okay, whereas psi square it has the physical meaning. It says the probability density of the electron. ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಇರ್ತದೋ ಇಲ್ವೋ ಅಂತ ಹೇಳುವಂಥದ್ದನ್ನ psi square will say. Okay, so if we plot psi and psi square against distance we get plot something like this. ಇದು ಅಷ್ಟೇ ಸ್ವಲ್ಪ ನೋಡ್ಕೊಳ್ಳಿ, ಬಿಕಾಸ್ ಇದರ ಮೇಲೆ ಬೇಸ್ಡ್ ಆಗಿ ಕೂಡ ಹೆಚ್ಚಾಗಿ ಪ್ರಾಬ್ಲಮ್ಸ್ಗಳು ಇರ್ತದೆ. ಸೊ ಇಫ್ ಯು ಪ್ಲಾಟ್ psi ವರ್ಸಸ್ ಆರ್ ಫಾರ್ 1s ಆರ್ಬಿಟಲ್ ಇಟ್ ಲುಕ್ಸ್ ಸಮಥಿಂಗ್ ಲೈಕ್ ದಿಸ್. ಓಕೆ, ಅದೇ ನಾವು 2s ಆರ್ಬಿಟಲ್ಗೆ ಇಟ್ decreases, reaches the 0 and then again decreases in the other, increases in the other direction, and then slowly it will decrease again. Okay, so this point where it crosses the x-axis, it is called as a node, where the probability of finding the electron is 0. Okay, node anta helidre it is the region where the probability of finding the electron is 0. ಅದಕ್ಕೆ ನಾವು ನೋಡ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಸೊ ಫಾರ್ 1s ಆರ್ಬಿಟಲ್ ಗೆ ನೋಡಿದ್ರೆ ದರ್ ಇಸ್ ನೋ ನೀಡ್, ನೋ ನೋಡ್. ಓಕೆ, ಈ ಸ್ಪೆರಿಕಲ್ ಶೇಪ್ ಅಂತ ಹೇಳಿದ್ರೆ ಏನರ್ಥ, ಎಲೆಕ್ಟ್ರಾನ್ ಕ್ಯಾನ್ ಬಿ ಫೌಂಡ್ ಎನಿವೇರ್ ಇನ್ ದಿಸ್ ರೀಜನ್, ಇನ್ ದಿಸ್ 3-dimensional ರೀಜನ್. ಅದಕ್ಕೆ ನಾವು ಸ್ಪೆರಿಕಲ್ ಶೇಪ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಓಕೆ, ಅದೇ ಈಗ ನೀವು p ಆರ್ಬಿಟಲ್ ಅನ್ನ ನೋಡಿ, p ಆರ್ಬಿಟಲ್ ವಿಲ್ ಬಿ ಸಮಥಿಂಗ್ ಲೈಕ್ ದಿಸ್. ಸೊ ಇನ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ರೀಜನ್, ದಿಸ್ ಹಿಯರ್ ದರ್ ಇಸ್ ದ ಪ್ರೊಬಾಬಿಲಿಟಿ ಆಫ್ ಫೈಂಡಿಂಗ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಇಸ್ 0. ಅದಕ್ಕೆ ನಾವು ನೋಡ್ ಅಂತ ಹೇಳುವಂತದ್ದು. ಓಕೆ, ಸೊ ಇಫ್ ಯು ಲುಕ್ ಎಟ್ ದಿಸ್ ಇಸ್ 1s. ಅದೇ ನಾವು 2s ಅನ್ನ ನೋಡಿದ್ರೆ ಇಟ್ ಈಸ್ ಸಮಥಿಂಗ್ ಲೈಕ್ ದಿಸ್. ಓಕೆ, ಈ ಆನಿಯನ್ ಅನ್ನ ನಾವು ಪೀಲ್ ಮಾಡುವಾಗ ಹೇಗೆ ಒಂದು ಶೆಲ್ ತರ ಇರ್ತದೆ, ಅದರ ಮೇಲೆ ಇನ್ನೊಂದು ಕವರ್ ತರ ಇರ್ತದೆ ಅಲ್ವಾ. ಸೊ ಆ ಫಸ್ಟ್ ಶೆಲ್ ಮತ್ತೆ ಸೆಕೆಂಡ್ ಶೆಲ್ ಅಥವಾ ಫಸ್ಟ್ ಕವರ್ ಮತ್ತೆ ಸೆಕೆಂಡ್ ಕವರ್ ಅಲ್ಲಿ ಆ ಗ್ಯಾಪ್ ಬರ್ತದೆ ನೋಡಿ, ದಟ್ ಈಸ್ ದ ನೋಡ್. ಅಲ್ಲಿ ಏನಿರುವುದಿಲ್ಲ. ಓಕೆ, ಸೊ ದಿಸ್ ರೀಜನ್, ಓಕೆ, ದಿಸ್ ಇಸ್ ದ ಫಸ್ಟ್ ಶೆಲ್. ಇಲ್ಲೆಲ್ಲ ವಿ ಹ್ಯಾವ್ ದ ಪ್ರೊಬಾಬಿಲಿಟಿ ಆಫ್ ಫೈಂಡಿಂಗ್ ದ ಎಲೆಕ್ಟ್ರಾನ್. ಓಕೆ, ಅಂಡ್ ದೆನ್ ದರ್ ಇಸ್ ಸಮ್ ಎಂಟಿ ಸ್ಪೇಸ್. ಆನಂತರ ಇಫ್ ಯು ಲುಕ್ ಎಟ್ ದ ಫೈಂಡಿಂಗ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ದಟ್ ವಿಲ್ ಬಿ ಹೀಗೆ. ಓಕೆ, so ಈ particular region where there is no probability, where there is no possibility of finding the electron, that is called as the node. Okay, so psi square if you plot, it is also something like this. The shape is something like this. Okay, and 1s 2s ಗೆ ನೋಡಿದ್ರೆ it will decrease and then again it will increase, reaches a peak value and then again it will decrease. Okay, so this region corresponds to the node. Okay, so node is a region of space where the probability of finding an electron is different. So different nodes can be calculated as n minus l. Radial node will be, so what is radial node? ರೇಡಿಯಲ್ ನೋಡ್ ಅಂತ ಹೇಳಿದ್ರೆ ಅದೇ 1s ಮತ್ತೆ 2s ಶೆಲ್ಗೆ ನಾನು ಹೇಳಿದೆ ಅಲ್ಲ, 1s ಮತ್ತೆ 2s ಶೆಲ್ಲಿನ ನಡುವೆ ಒಂದು ಎಂಟಿ ಸ್ಪೇಸ್ ಇರ್ತದೆ. ಓಕೆ, ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಅ ರೇಡಿಯಲ್ ನೋಡ್. ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ಅ ರೀಜನ್ ಬಿಟ್ವೀನ್ ಟೂ ಸಕ್ಸೆಸಿವ್ ಆರ್ಬಿಟಲ್ಸ್, ರೀಜನ್ ಬಿಟ್ವೀನ್ ಟೂ ಸಕ್ಸೆಸಿವ್ ಆರ್ಬಿಟ್ಸ್. ಓಕೆ, ಸೊ ಆ ರೀಜನ್ಗೆ where there's a empty space ಅಂತ ಹೇಳಿದ್ರೆ ಇಟ್ ಇಸ್ where there's probability finding the electron is 0. ಸೊ ಅದಕ್ಕೆ ನಾವು ರೇಡಿಯಲ್ ನೋಡ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಅಂಡ್ ದೆನ್ angular node, L is here, L corresponds to n this angular node will be equal to L value. Anyway, we will come to, we will discuss about n, L, etc. bit later here in this session only. So L anta helidre it is equal to, I mean angular node will be equal to the value of L. So L anta helidre it is angular node, or it is also called as a nodal plane. It is the plane which separates the two lobe. For example, okay, idu nodi 2px orbital alli there is one plane here which passes through the nucleus. Okay, which passes through the nucleus and where there is a probability of finding the electron is 0. Idella ಆ plane anna we have called it as the angular node. Okay, s orbital ge there is no angular node. Ade p orbital ge adaga there is one angular node. And d orbital if you look at, there is two such planes alpha, there is two such planes. Okay, so that is called as a angular, so that such plane is called as a angular node, and the number of angular node will be equal to the value of L. So total number of nodes will be n minus 1. So first shell alli ಎಷ್ಟು node ಇರ್ತದೆ? So first shell alli n minus 1 value. First shell ಅಂತ ಹೇಳಿದ್ರೆ the value of n will be 1. ಹಾಗಾಗಿ node will be 1 minus 1, it is 0. If you look at the second s, 2s, then the node will be second shell, n value is 2 minus 1. So there is one node. ಇದು ಅಷ್ಟೇ very important formula. ತುಂಬಾ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇದ್ರ ಮೇಲೆ ಬೇಸ್ಡ್ ಆಗಿ ಬರ್ತದೆ. Okay, so keep this in your mind. Radial node ಅಂತ radial node will be equal to n minus L minus 1. angular node will be equal to value of L, and total number of node will be equal to n minus 1. Okay, and when we work out the problems you will get to know about this more, and there I'll explain you more. Okay, yes, now with this Schrodinger wave equation has given it has certain the solution of the Schrodinger wave equation gave certain numbers called as the quantum numbers. So what this quantum number and its physical meaning, physical significance, let us briefly go through. So there were 4 solutions. ಈಗ mx plus y is equal to mx plus c ಅಂತ ಹೇಳಿದಾಗ ಒಂದೆರಡು ಈಕ್ವೇಶನ್ ಅನ್ನ ಕೊಟ್ರೆ we'll be able to get the value of y ಮತ್ತೆ x ಅಲ್ವಾ. So that value of y and x, it is called as a solution. ಅದೇ ರೀತಿ Schrodinger wave equation ಪ್ರತಿ orbital when we solve that equation we will get certain numbers, certain values, certain solutions, and that solution is called as a quantum number. So every orbit has certain solutions of certain numbers associated with it. Every orbit, every orbital has certain numbers associated with it, which characterize that orbit, which characterize that orbital. Okay, and that is called as a quantum number. So one quantum number, for the first quantum number is the principal quantum number. It is written as small letter n, designated as small letter n. So what does it say? It says the position and the energy of the orbital, the exact path, or it is also the main energy level we can say. Okay, so the principal quantum number tells you the main energy level of that electron. Okay, that is the principal quantum number, and the number of allowed orbital in a shell will be n square. So first shell alli the value of n will be 1, and the number of allowed orbital is also 1 square ಅಂತ ಹೇಳಿದ್ರೆ 1. ಅದೇ second shell ಗೆ ಹೋಗಿ, so the number n value will be 2 alpha. How many orbitals can exist? 2 square, so there are 4 orbitals, 2s orbital, and there are 3 p orbitals. So totally there are 4 orbitals. Go to the third shell. Third shell alli the value of n will be 3. So 3 square. So totally 9 orbitals can exist in that shell. Orbit ಹೇಳಿದ್ರೆ main energy level, orbital ಹೇಳಿದ್ರೆ sub levels ಅಂತ ಹೇಳ್ಬೋದು. Okay, so in the third shell, third orbit, 9 orbitals can exist. 3s, then 3p, okay, and then there are 5 3d orbitals. So totally 9 orbitals can exist. So the value of n gives you the total number of allowed orbitals in the shell. And the second quantum number is azimuthal quantum number. It is written as small letter L, designated as small letter L. So it gives you the subshells. So these subshells in the main energy level, main shell. So these subshells can be s, p, d, f orbital galu alpha, 3 dimensions. So it also tells you the shape of the subshells, or the shape of the orbital. Okay, so the value of L, what are the L values possible for any n value? So for any given n value, the L can have values ranging from 0 to n minus 1. So first shell alli what is a possible L value? It is 1 minus 0. So L value is only 0. ಆಯ್ತಾ? ಸೆಕೆಂಡ್ ಶೆಲ್ಲಿಗೆ ಬಂದಾಗ it can have values 0 ಆನಂತರ second shell. Okay, so what are the possible L values? Possible L values will be 0 and 2 minus 1, so 1. There are 2 L values possible. Yes, L equal to 0 corresponds to s orbital, L equal to 1 corresponds to p orbital. So value of L will be, if it is 0, 1, 2, 3, 4, etc., the value, they correspond to orbital s, p, d, f, g, h, etc. ಆಯ್ತಾ? L ವ್ಯಾಲ್ಯೂ ಅನ್ನು ನೋಡ್ಕೊಂಡು ಅದು ಯಾವ ಆರ್ಬಿಟಲ್ ಅಂತ ನಾವು ಹೇಳ್ಬೋದು. ಇಟ್ ಟೆಲ್ಸ್ ಅಸ್ the shape of the orbital. S value ಅಂತ ಹೇಳಿದ್ರೆ it is a spherical orbital, p orbital ಅಂತ ಹೇಳಿದ್ರೆ it is a dumbbell orbital, d orbital ಹೇಳಿದ್ರೆ double dumbbell shape. Okay, so the path in which the electron is moving, exact path in which it is, in the shape in which the orbital is moving, that is indicated by the L value. Okay, so the number of subshells in main energy level will be equal to N. So first shell alli the subshell is, there is only one subshell possible, 1s, there is only one subshell possible. At the second level ge bandaga there are 3 subshells possible. Yavudella 0 ಮತ್ತೆ 1. ಅದೇ ನಾವು ಥರ್ಡ್ ಶೆಲ್ಗೆ ಬಂದಾಗ, ಥರ್ಡ್ ಮೇನ್ ಎನರ್ಜಿ ಲೆವೆಲ್ ಅಥವಾ ಥರ್ಡ್ ಆರ್ಬಿಟ್ ಗೆ ಬಂದಾಗ we can have 3 subshells. So what are they? S, P and D. Clear? So ಎಷ್ಟು subshell ಇರಬಹುದು ಅಂತ ಹೇಳುವಂತದ್ದನ್ನ it is given by this formula. The number of subshells in main energy level will be equal to N. ಇದು ಕೂಡ ಅಷ್ಟೇ very important, ಈ quantum number significance ಯಾಕಂತ ಹೇಳಿದ್ರೆ ಅದರ ಮೇಲೆ ಬೇಸ್ಡ್ ಆಗಿ ತುಂಬಾ ಪ್ರಾಬ್ಲಮ್ಸ್ ಗಳು ಇರ್ತವೆ. Okay, and then magnetic quantum number ML. So it tells you the spatial orientation of the orbital with respect to standard state of coordinate axis. So coordinate axis ಅಲ್ಲಿ ಯಾವ ರೀತಿ ಈ ಆರ್ಬಿಟಲ್ ಓರಿಯೆಂಟ್ ಆಗಿದೆ ಅಂತ ಹೇಳುವಂತದನ್ನ ಹೇಳ್ತದೆ. Okay, so the values taken by M will be -L to +L including 0. Okay, so ಈಗ say L value 2 ಅಂತ ಇದ್ರೆ ಸೆಕೆಂಡ್ ಶೆಲ್ ಅಲ್ಲಿ L value ಇದ್ರೆ, so second shell if we take, so the N value will be 2. What are the L values possible? It is 0 and 1. So what are the ML values possible? So quantum magnetic number possible. So 0 ke it is only 1 possible, that is 0. Ade L value 1 adaga it can have -1 value, it can have 0 and it can have +1. So what does it indicate? The orbital is, if it is with respect to x-axis, it is in the x-axis, it is opposite to the okay, I mean the 3 dimensions, 3 directions it is indicating x direction, y direction and z direction. It says px, py, pz. Px, okay, one indicates px, other one indicates py and the third one indicates pz, like that. Okay, exactly in which directions the spatial orientation in the 3 coordinate axis, in which direction it is oriented, that is indicated by these M values. Okay, number of subshells will be equal to 2L plus 1. Okay, and then spin quantum number anta hedidre how exactly the electron is revolving, whether it is moving in the clockwise direction or whether it is moving in the anti-clockwise direction. Clockwise direction alli move agta unta athwa anti-clockwise direction alli move agta unta anta heluvantadanna this ms value will tell. So it tells you the orientation of the electron in the orbital. So this can take only 2 values, plus half and minus half value it can take. So maximum number of electron in any in a main energy level, it is given by 2n square. Maximum number of electrons in the main energy level. So first energy level alli ಎಷ್ಟು ಇರಬಹುದು, 2 into 1 square. So there are only 2 electrons can exist in the first energy level. Other, if you look at the second energy level, second shell, so how many electrons it can have? Maximum 2 into 2 square. So 4 into 2, that is 8 electrons can exist in the second shell alva. 2s alli 2 ananತರ 2p alli prati p orbital alli 2 totally 6 here and 2 here, so totally 8 electrons. So maximum number of electron in main energy level, in any energy level, it is given by 2n square. Okay, and then in this chapter we have discussed about rules for filling the electrons. Okay, so there are 3 rules: Upper principle, Hund's rule of maximum multiplicity and Pauli's exclusion principle. So as per this Upper principle, electrons, when we are filling the electron, where does the electron enter? Because we have, when we say an atom, at the center nucleus will be there and then it is surrounded by various orbits, various paths. So when an electron enters this atomic species, where it can go, electron has to go to the various orbitals in the increasing energy level. So initially it should enter into the least energy level first. So the lowest energy level will be filled first. That is what is indicated by Bohr principle. A new electron enters in an empty orbital for which the value of n plus L is minimum. So again, energy in third now nodidaga n plus L anna both we have to consider. Okay, so whichever has least n plus L value, for that the electron will enter. Okay, suppose if two energy levels have same value of n plus L, that is say 4s and 3d. If we look at ಅಲ್ಲ 3d ಅಲ್ಲ ಯಾವುದು 4p ಮತ್ತೆ 3d ಅನ್ನ ನೋಡಿ. ಸೊ ವ್ಯಾಲ್ಯೂ ಆಫ್ n ಹಿಯರ್ ಇಟ್ ಈಸ್ 4 ಅಲ್ವಾ. p ಅಂತ ಹೇಳಿದ್ರೆ what is the value of L here? Value of L will be 1. Okay, and in 3d orbital the value of n is 3 and value of L will be 2, correct alla? So what is the value of n plus L? 4 plus 1 5, and here also 4 plus 3 plus 2, it is 5. So as per Bohr principle, the orbital which has the least n plus n value will be filled by the electron first. Alpha. And if suppose n plus L value is same for two orbital, the electron will enter into the orbital which has a lower value of n. So here in this case 4p and 3d. Okay, so n value is 4, L value is 1, and therefore n plus L is 5. And 3d, n value is 3, L value is 2, so n plus L value is 5. So both these orbital have same energy. So in that case, same n plus L value. In that case, where does the electron will go? Electron will enter into the orbital which has least n value. So the 3d should fill first before 4p. Clear? So in general, the orbital which has n plus L value lowest will be filled first. And if two orbital have same n plus L value, then the orbital with lower value of n will be filled first. Clear? Okay, and then Hund's rule of maximum multiplicity. So electrons never pair up until each orbital of a given subshell contains one electron each. For example, in the second shell, okay, if electron is entering into the p orbital, for example, oxygen 2s2, it will be filled first, and then the remaining electron should enter into the p orbital. So there are 3 p orbitals and 4 electron needs to be filled. So yellige hogtade? So p orbital, when we say, we have px, we have p pi, and we have pz alva. Px, p pi, and pz. Okay, so we have 4 electrons. So first each orbital will be occupied singly. Nantrane pairing will take place. Okay, electrons never pair. ಈಗ ಇದು 4 electron ಇದೆ. So first 2 ಇಲ್ಲಿ, next 2 ಇಲ್ಲಿ ಬಂದ್ರೆ, so no, that is not possible. That is not the least energy state. Okay, so this is wrong. So each orbital will be occupied single first, and then the pairing will take place. Okay, last principle used here is Pauli's exclusion principle. So as per Pauli's exclusion principle, no two electrons in an atom can have same set of all 4 quantum numbers. Andre n value, L value, m value, or it is also written as ml value, and ms value. So no two electron can have same set of these 4 quantum numbers. At least ಒಂದಾದ್ರೂ change ಇರಬೇಕು. Okay, so that is what is said by this principle, Pauli's exclusion principle. So filling of electron, see, it is follows this order. 1s will be filled first, and then it goes to the 2s, and then it goes to the 2p, and then comes to the 3s, and then comes to 3p, and then comes to 4s, and then comes to 3d. After 4s, it is a 3d will be filled, and then comes 4p, and then comes 5s, and then comes 4d, etc. Okay, so this is the order. Clear? So this is a summary of the second chapter, that is structure of atom. So main agi ನಮ್ಮ ಕ್ವಾಂಟಮ್ ನಂಬರ್ಸ್ಗಳಿಗೆ ಫಿಲ್ಲಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್, ಅದು ಆನಂತರ ನಮ್ಮ ಲಾಂಬ್ಡಾ ವ್ಯಾಲ್ಯೂ ಕ್ಯಾಲ್ಕುಲೇಷನ್, de Broglie equations, uncertainty principle, adu very important. Uh, and then what else is there? Node calculations, that is very important here. Okay. And radii calculation and energy calculations. Okay, Bohr orbital energy calculation, radius calculation, velocity calculations for hydrogen and hydrogen like species. All those concepts are very, very, very important. Okay, I hope it is clear to you. The next session we will discuss some of the problems. Okay, I'll send some problems based on this. Try to solve it. Okay, yeah.